Good evening, everybody. Welcome to another edition of Final Countdown. So this is week 6, day number 2. Let's dive back into work. Right. Have a look. A small ball started from rest, rising through a viscous liquid. Rising through a viscous liquid. So keyword here, viscous. Viscous means you apply laws connected to viscosity. There, laws connected to viscosity, and reaches its terminal velocity. Right. So they are telling you reaches its terminal velocity. The upthrust on the ball is greater than the weight of the ball. Yeah. So rises through, going up. Going up. So here upthrust is of course greater than weight. Upthrust is of course greater than the weight. Upthrust is weight plus viscous force. Upthrust is weight plus viscous force. Okay. That means guaranteed upthrust is greater than the weight. Statement A is correct. At the initial moment, the motion of the viscous force on the ball is 0. The viscous force on the ball is 0. Correct. F equals 6 by eta RV. Starting from rest means initial velocity is 0. 6 pi eta r. So viscous force is going to be 0. B is also correct. The acceleration of the ball remains constant until the ball reaches terminal velocity. Wrong. If I draw the VT graph, all of you can see this. Reaches terminal velocity. What can you say about the acceleration time graph? Acceleration reduces, becomes what? 0. It is not a constant acceleration. Statement C is wrong. A and B is true. A and B is true. Okay. Statement C is wrong. A and B is true. Right? Okay. Moving on. 10 people are standing on a circle. When one of them shouts, the intensity level at the center of the circle is 50 decibels. So one person shouts, beta equal 10 log I1 over IO, 50 decibels, 10 log I1 divided by IO. From this 0 cancel off. I1 is equal to 10 to the power 5 IO. 10 to the power 5 IO. Right. If all 10 people shout at the same time, each producing the above same sound level, the intensity of sound. So all 10 people shout. 10 times I1 over IO. 10 times IO over IO. So 10 log 10 to the power 5 IO over IO here. These two cancel off. Here 10 to the power 6. 60 decibel. The intense level at the center becomes 60 decibel. Answer number 3. Answer number 3. 22. Answer number 3. Figure shows a PV diagram of a perfect gas. Subjected to a cyclic process. All of you all know cyclic processes. What's happening in a cyclic process? Internal energy change will be 0. Depending on whether it's clockwise or anti-clockwise, there will be a work output or a work input. Right. If you look at this is a clockwise cycle. Clockwise cycle means there is a network output. Network output means area inside the cycle. Area inside the cycle. So work done plus half base into height plus 3 joules. Now cyclic process, if you apply delta Q equals delta U plus delta W, internal energy change is 0, here 3 joules. Delta Q is equal to plus 3 joules. So there is a net heat input. So 3 joules of heat is absorbed by the system. There you go. Correct answer is answer number 1. Correct answer is answer number 1. Right. Moving forward. A photosensitive surface, now we have spoken about this many times, is illuminated separately by different wavelengths, so different frequencies. On the 3 occasions, the intensity per second of light used kept at the same. The intensity same means number of photoelectrons emitted will be the same. Number of photoelectrons emitted will be the same. Right. So number of photoelectrons emitted will be the same means it can't be different currents. It can't be different currents. It should be a single current. Okay? It should be a single current. So first one, second one wrong. First one, second one wrong. Right. If you look at this, HF equals work function plus KE max. Maximum kinetic energy. Maximum kinetic energy. Simplify this, HC over lambda. So greater lambda means lesser frequency. Here if you look, F1 is smaller than, F2 is smaller than F3. F3 is larger, higher frequency. HF minus work function, that is equal to KE max, maximum kinetic energy. Maximum kinetic energy EVS. HF minus work function 5. Right. Carefully look. Greater the frequency, greater HF means HF minus 5 is also large. Stopping voltage is also large. So F3 will have the greater frequency, greater stopping voltage. F3 means lambda 3. Greater stopping voltage. It can't be answer 3. It can't be answer 5. Only possible solution is answer number 5. So same intensity, same photo current. Same intensity, same photo current. But depending on the incident frequency, the stopping voltage will be different. Greater the frequency, greater the stopping voltage. So smaller lambda means greater frequency. Greater frequency means greater stopping voltage. There you go. So the correct answer is answer number 4. Right there. Same intensity of light indicates that. The amount of photoelectrons emitted per second will be the same. Depending on the incident frequency, the stopping voltage will change. I have given you the order. The stopping voltage will change. Right. Okay. 6 resistors, each of 50 ohm, are connected to the circuit. There you go. 10 volt battery has negligible internal resistance. The potential difference between P and Q. Right. Let's first look at this cell. Current is going this way, I1. Current will go this way, I2. Then I1 plus I2 will go through here. I1 plus I2 will go through there. So if you look at this carefully, apply Kirchhoff law here. Sum of EMF equals sum of potential differences. If you look at this carefully, 10 equals 50 150, 100, 150, 200. 200 I1. I1 equal 0.05 amperes. No need to think about this. Now what do? Now connect P and Q with an imaginary mathematical line. Imaginary mathematical line. Once you connect it with an imaginary mathematical line, you all apply Kirchhoff here. There you go, Kirchhoff law there. I'll use orange to do the calculation also. Sum of EMF equals sum of potential differences. Minus to plus positive. Loop is going from Q to P. Here loop is going from Q to P. Voltage from Q to P plus 50 times I1. 10 equal VQP. 50 times I1 0.05. So 250 2.5. VQP is equal to 10 minus 2.5. 7.5 volts. Remember VQP, potential difference 7.5 volts, already found. So whenever they ask to find the potential difference, join it, apply a loop there. Whatever loop you applied, the loop traveling parallel to the line you joined. Here it's going from Q to P. That means VQP, Q potential larger than P potential. From this you can get your answer 7.5 volts. 7.5 volts. Right? Okay. Consider the following statements regarding alpha and beta particles. All of you all know alpha particles are helium atoms. Alpha particles are actually helium atoms, helium 42. Beta particles are, beta minus means electrons. Electron 0 minus 1. Right? 0 minus 1. Remember this part is separate. Right? Okay. Now what? Both alpha and beta particles travel with the speed of light. Wrong. Alpha particles travel with 6% the speed of light. Beta particles travel with about 98% the speed of light. 98% the speed of light. Gamma travels at the speed of light. Okay. Generally, alpha particles penetrate deeper materials than beta. Wrong. A is also wrong, B is also wrong. Alpha, low penetration. Low penetration. Here cardboard. Cardboard. Here slightly higher penetration. Higher than alpha. Example, aluminium foil. Both alpha beta particles can ionize atoms when they travel through materials. Ionization ability is there, that's a different story. Because both have charge. Answer 2 is correct. Right there. Both particles, so I given you the values. Both particles have a charge. Therefore, there is ionization ability. Therefore, there is ionization ability. So I given you the speed, alpha beta, penetration ability, gamma penetration even more. Okay, right. Which of the following figures shows the directions of the frictional force? So when you are pedaling, let's say this is the road. Let's say this is the road. The back wheel is pushing the flow backwards. Back wheel is pushing the flow backwards. Back wheel is pushing the flow backwards. Flow is pushing the wheel forward. Right. This is like a sliding wheel. This is pushing the flow forward. Friction is backwards. Correct answer is answer 2. Correct answer is answer 2. Okay, no? Right. An object of mass m moving on a frictionless plane passes point x with a velocity v, rises up a frictionless plane to a height h. If a certain object mass m over 2 has a velocity v over t, if you look at this, gravitational potential energy. So kinetic energy loss equals gain in gravitational potential energy. Kinetic energy loss is half mv squared minus 0. Gain is mgh. Mm cancel off. V squared equal 2gh. V squared proportional to h, independent of the mass. Independent of the mass. Right. Independent of mass. These are very basic work. Okay. So it's independent of mass because the mass here and the mass here will cancel off. Now they are telling you the mass is MO2. Don't worry about the mass. Independent. Velocity is V over 2. What is the height travel? Equation 1, equation 2. Divide the second equation by the first equation. H dash divided by h. V squared over 4 divided by V squared. H dash equals h over 4. H dash equals h over 4. Eighth one correct answer, answer number 2. Eighth one correct answer, answer number 2. Right there. The height travelled is independent of the mass. The height travelled is independent of the mass. Right. Figure 1 shows a book placed on top of a book B, which rests on the floor. Figure 2 shows the free body diagram of the forces PQR acting on the box. So what can you say? Upward forces, balancers, downward forces. Q equal P plus R. That's all we can say. This statement is wrong. Force on the floor exerted by the box is indicated by P. Wrong, that's the weight. Force on the floor exerted by the box is indicated by Q. Force on the floor, wrong. Flow exerts a force on the box. These are force exerted on the box by the book is indicated by R. That's correct. Correct statement is answer number 4. Correct statement is answer number 4. Right. MCQ number 30. MCQ number 30. Beam of electron enters a region. Two charge plates. So electron enters here. Remember, when electron enters, there will be a force towards the positive charge plate. Electric force upwards. Potential difference across the plates 200 volt. Here you go. Potential difference across the plate 200 volt. Magnetic field required to keep the beam in the y direction. Y direction means undeviated. So undeviated means upward electric force should balance downward magnetic force. Apply left hand rule. Field, electron going that way means current in the opposite direction. Electron going that way means current is in the opposite direction. Force downwards. So magnetic force is acting in the downward direction. Right. So now we know field, left hand rule. Field, current is not that way, opposite way, force downward. Right. Undeviated means upward electric force balances downward magnetic force. Electric force is equal to EQ. Magnetic force equals BQV. Don't forget. QQ cancel off. So here they are asking electric field potential difference over distance. Potential difference over distance. Magnetic field is equal to, magnetic field we don't know, we have to find it. Velocity is 10 to the power 6. Simplify this carefully. Potential difference 200. Distance between the plates 1 centimeter, convert to meter. B 10 to the power 6. B is equal to 2 10 to the power 4 divided by 10 to the power 6. 0.02 Tesla or 2 10 to the power minus 2 acting into the paper. So correct answer is answer number 4. Correct answer is answer number 4. Right there. A negative charge is attracted towards a positive plate. A negative charge is attracted towards the positive plate. A negative charge is attracted towards the positive plate. This means there will be a electric force in the upward direction. This means there will be a electric force in the upward direction. Electric force in the upward direction. And this electric force must be balanced by a magnetic force downwards. And this electric force must be balanced by a magnetic force downwards. Must be balanced by a magnetic force downwards. So the charges will travel undeviated. So the charges will travel undeviated. Charges will travel undeviated. Right now? So here you go. Right. Okay. Alarm is sounded in a car at least when the car is started while the door is open, or the car is started while the driver is not wearing a seat belt. So car is started is the main condition, door is open or car is started, driver is not wearing a seat belt. Three sensors A and B provide signals such that A equals 1, at least one door is open. B equal 1, engine is running. C equal 1 when driver is not wearing the seat belt. Yeah. So what are your conditions to get the alarm? Conditions for getting the alarm is engine should be running. So door closed, okay, engine is running, seat belt not worn, not wearing the seat belt, right? Not door open, engine running, wearing the seat belt, wearing the seat belt. Not A bar. One door is open. Door is open, engine is running, door is open, engine is running. Wait to do. What is A equal 1? When door is open. So when door is open. Door is not open, engine is running, driver is not wearing. Door is open, engine is running, driver is wearing. Next one. A, B, C. A, B and C. So these three conditions satisfied means problem solved. So find A bar, B, C. Guaranteed B should be 1. A bar, B, C bar. This won't come. A bar, B, C bar. This won't come. Five outputs, no. A, B, C, not only one. A bar, B, C. A, B, C bar. A, B, C. Correct answer is answer 5. Correct answer is answer 5. Okay, no? Door is closed, engine running, driver is not wearing seat belt. Door is open, engine running, driver is wearing the seat belt. Door is open, seat belt is also not put, engine is running. Under these conditions, alarm should ring. Alarm should ring means F should be 1. Okay, no? Right. Potential divider circuit shown is powered by 30 DC. Potential difference between P and Q, this is 5 volts. So here 5 volt means these are parallel. So here 60, these two are parallel means multiply both the resistors, and remember, multiply both the resistors, divide by the addition. At this instant, the potential difference here is, at this distance, the potential difference is 5 volt. So how do you find 5 volt? Resistor into total voltage, 48 R divided by R plus 48 times 30, divide by the addition, 60 plus 48 R plus 48. Simplify it. Simplify it. Here 5 times 60 plus 48 R plus 48. R 30. R plus 48. Common denominator here. 30 times 1, 30 times 6. You can take 12 out. 5 plus 4R, R plus 48. 6 times 48R, R plus 48. 12 times 1, 12 times 4. Cross multiply. 5R plus 24 plus 4R, R plus 48. 24R, R plus 48. R plus 48, R plus 48. Now simplify. 240 minus 9R. 240 minus 9R. 240 minus 9R. 24R. 240 equals 15R. Be a bit careful in your calculations. 48R times 30 divided by the addition. Simplify it carefully. 5 times 1, 5 times 6. 48 times 6. Here 12 take it out. 5. 4R. 5R plus 240 plus 4R, R plus 48. 24R. R plus 48 cancel off. 9R plus 240 is 24R. Take it that side. 15R. Simplify and see. 3 times 5, 3 times 8, 0. R equal 16 ohm. R equal 16 ohm, answer number 3. R equal 16 ohm, answer number 3. Okay, no? Answer number 3. So we have applied potential divider and then solve the problem. Clear? Solve the problem. Right. An image of an erect virtual object which is situated between the lens and its focus, formed by a diverging lens, is the image of an erect virtual object. Erect virtual object, diminished, upright, virtual image. Virtual erect smaller than the object. 13, answer number 4. The image of a erect virtual object. Be careful. What do you mean by erect virtual object? Erect virtual objects can be found when light rays converge or seem to like converge. Okay. Virtual object means incident rays seem like to meet. Incident rays seem like to meet. What will happen? Diverging rays will meet somewhere here. So these virtual, these real. So it will image distance large, no? Real erect larger than the object. So virtual object, virtual object. So if this was a real object, this one. Virtual object, this one. Virtual object, upright, small object. Image is real, upright, larger than the object. Upright, larger than the object. Okay, no? A monochromatic ray of light is incident upon a prism of refracting angle A and emerges as shown in the diagram. Here you go. Consider the following statements regarding angle of deviation. As I is increased from 0, the value D passes through a minimum. Correct. So if I keep on increasing angle of incidence, there will be a minimum deviation taking place. D is 0 when ray is incident to the prism normally. Wrong. If it's coming normally, here 90 means, here A means, 90 minus A, this is A. Depending on how large that is, it will go along or come here. So there will be a deviation. B is wrong. For a given value of I, D does not depend on A. D does not depend on A. Wrong. Minimum deviation, so angle of deviation or whatever, I1 plus I2 minus R1 plus R2. I1 plus I2 minus prism angle. Minus prism angle. So it depends on the prism angle. Only A is correct. Answer 1. 14th one, answer 1. 14th one, answer 1. Right. The variation of volume with temperature theta of an ideal gas of mass m, constant pressure P is shown by the line H. Shown by the line H. The variation of V theta for the same ideal gas mass 2m at constant pressure. Remember, PV is equal to nRT. PV equal mass RT over molar mass. This is volume temperature graph. Volume temperature graph. P is equal to mR over Pm times T. mR over Pm, theta plus 273 is your Kelvin value. So V is equal to mR over Pm plus mR over Pm 273. Graph is of the form y is equal to mx plus c. Don't forget theta here, right? What are they saying? Constant pressure P. Constant pressure P line H. Right, line H. Y-intercept is 2. Y-intercept is 2. So if I write here, 2 is equal to simple MR 273, capital M pressure. Now they are saying same ideal gas mass 2m, pressure P over 2. So what is your y-intercept? 2m R 273, molar mass, pressure P over 2. Pressure P over 2. This goes on top. 4 times simple M R 273, capital M, capital P. This part is 2. 4 times 2 is your y-intercept. That's going to be 8. Check which graph you have y-intercept 8. Only one answer. Answer F. Answer F. So from this you know the graph is, follow this carefully. Yeah? From this you know the graph is y equal mx plus c. The y-intercept will depend on what you call the pressure mass values. Unknown y-intercept, this part we can substitute 2. Y-intercept is 8. Correct answer is answer number 1. Correct answer is answer number 1. Okay, no? So the moment you look at this, you should know y equal mx plus c form. You should know how to quickly convert Kelvin temperature to Celsius temperature. Kelvin temperature to Celsius temperature. Right. The diode in the circuit shown has forward bias resistance. Forward bias, 0 forward bias resistance. And a reverse breakdown voltage 75. Breakdown you remember, no? Can you remember? Here IV graph. IV graph. Here 75. 75. Right. Voltmeter reads 12 volt. So voltmeter reading is 12 volt. When the terminals of the diode are reversed, the voltmeter reading is. So look at this position. So potential difference equal IR. 12 equals current in the main circuit, ideal instruments, resistance 2. I1 equals 6 amperes. I1 equals 6 amperes. Forward bias resistance is 0. Current will equally divide. Here 3 ampere, here 3 ampere. Right, 3 ampere, 3 ampere. Now what are they asking you? Let's find the battery value. 3 times 2 is going to be 6 volt. Here 6 volt, here 12 volt, this is 18 volts. Already EMF found. Already EMF found. Here 12 volt, here 12 volt, here 6 volt. These two are 6. 6 means parallel. So this whole thing is 6. 6 and 12, 18. Battery EMF is 18. Right. Now they are telling you, okay, now you do the question. Voltmeter connected here. Battery reversed. Diode terminals reversed. Here 2 ohm. Here 2 ohm. Now what? Remember reverse bias. Reverse bias. Current won't go through. Current will go through the main circuit, outer circuit. Apply Kirchhoff's law. Apply Kirchhoff law. Sum of EMF equals sum of potential differences. 18 4 times I2. Simplified, I2 is equal to 18 divided by 4. 4.5 amperes. 4.5 amperes. So 4.5 multiplied by 2, 9 volts. Answer is answer number 3. 16, answer number 3. Right there. When we reverse the terminals of the diode, current will not pass through. Current will not pass through the diode. Current will not pass through the diode. All currents will pass through the outer cycle. All currents will pass through the outer cycle. Okay. Right. A non-viscous incompressible fluid. Non-viscous incompressible means Bernoulli directly. The variation of pressure. Larger area, larger pressure. Smaller area, smaller pressure. Answer is answer number 4. Area is proportional to inversely velocity proportional to pressure. Large area, low velocity. Low velocity means 1 over V is high. 1 over V is high. That means pressure is high. Large area, larger pressure. Large area, larger pressure. Right. A uniform circular disk of radius r and mass m rotates with angular velocity omega in the horizontal direction. The moment of inertia of the disk is described by half mr squared. Tray ball is placed gently on the edge of the disk. New angular velocity. So here you go. Disk is rotating with angular velocity omega. Moment of inertia half mr squared. Now on the same disk, we are placing a mass here, m over 8, radius is r. New moment of inertia, disk is also rotating, half mr squared, mass is also rotating, m over 8 r squared. Simplified, common denominator 8, 4 and 1, 5 mr squared. Is there external torque? Yes, but it's not passing through the axis of rotation. Therefore, we can say total initial angular momentum equals total final angular momentum. Total initial angular momentum is half m r squared omega. Total final is 5m r squared 8 over omega 1 or omega 2. mr squared cancel off. Omega 2 is equal to 4 omega divided by 5. 4 omega divided by 5. 4 omega over 5 means answer number 3. 4 omega 5 means answer number 3. Right. Question number 19. A light travels in water, refractive index N1 is incident on air-water boundary at the critical angle. So at the critical angle, air-water boundary. So goes along the boundary, N1 air. I can write here N1 sin C, NA sin 90, right? Okay. So N1 or sin C is equal to 1 over N1. Okay. 1 over N1. Now what? between the water air layer, we bring another liquid with refractive index N1. Angle of refraction of light. The angle of refraction of light means light rays go like this. Rarer, denser. Denser. Denser means not the normal density, optical density. They have not told you, so you know which direction. Let's say towards 0. Here same angle C, this angle is R. Look, N1 sin C is N2 sin R. N2 sin R. Now what? Sin C is 1 over N1. N2 sin R. Sin R is equal to 1 over N2. R is sin inverse 1 over N2. 19th answer number 1. 19th answer number 1. R equals sin inverse 1 over N2. 1 over N2. Right? Okay? Right now? The value of the variable resistor R that minimizes the heat generation through 5 ohm resistor. Minimizes the heat generation through 5 ohm means current passing through here 0. Current is passing through there 0. That's what you mean by minimizing. Current passing through 0 means potential here and here same. Potential here and here same. Potential there and there same means whose bridge? Wheatstone bridge. So here the battery, to simplify this, 1 ohm, 4 ohm, 5 ohm connected here, 5 ohm connected there, here 12 ohm, here R and 10, 10R divided by 10 plus R, 10 times R divided by addition. Here 10 volt. Now for current doesn't pass through this. The power loss here minimum is squared R, EI or V squared over R, one of the two. So current through this, potential difference here 0 or current through this is 0. Right. Let's see what's the condition. Wheatstone bridge condition. So current through the circuit here 0 means minimum power loss. 1 over 4 is equal to 10R divided by 10 plus R divided by 12. 4 times 1, 4 times 3 cross multiply. 10R divided by 10 plus R. 30 plus 3R equals 10R. Be a bit careful. 1 and 4. Oh, sorry. 4 and 1 here 3. Yeah? 4 and 1 here 3. Here 12. Yes. Here 12. This part there is no resistor. So 3 is here. Sorry. 3 is here. First multiply. First multiply. Three times 3, 9. 3 times 3, 9. So when you do it, sometimes you might make a calculation error, but quickly you can go and check. 1 and 2, 3 here. Series. No? Here 4, 5 in the middle. Here 12. Here there is nothing. No resistor here. But these two are parallel. Right. So here there is 3 times 3, 9. 90 plus 9R equal 10R. That means R is equal to 90 ohm. Check and see. R equal 90 ohm. 90 times 10, 900 divided by 100, 9. 9 divided by 12, 304. Here also 304. Correct. 90 ohm. Correct answer is answer number 5. Correct answer is answer number 5. Right? That is more sentence. For the power loss to be minimum, there should not be current passing through the 5 ohm resistor. There should not be current passing through the 5 ohm resistor. There should not be current passing through the 5 ohm resistor. This means it must obey the Wheatstone bridge. It must obey the Wheatstone bridge. It must obey the Wheatstone bridge. Okay, no? Right. A student wants to determine the specific latent heat of fusion of ice. Practical done. Using method of mixtures in the school laboratory. A calorimeter containing water, ice and other necessary items for the experiment have been provided. Should the initial temperature of water inside the calorimeter be below, above or at room temperature? It must be above room temperature. Above room temperature. What's the reason? We start from a temperature above, we add ice until the temperature is what? 5 degrees below room temperature. What do you call this? Heat compensation method. Let's say it must be above room temperature. It must be above room temperature. Right. What's the reason for this? What's the reason for this? To compensate the heat. To compensate the heat loss which may occur to the environment. Which may occur to the environment. Which may occur to the environment. We start the experiment. We start the experiment above room temperature. Above room temperature. Above room temperature. And we insert ice until it is below room temperature. Below room temperature. Okay, no? Until it is below room temperature. So to compensate the heat loss which may occur in the environment, we start the experiment above room temperature and we insert ice until it's below room temperature. Right. Give the precautionary steps that the student should follow when ice is added to the calorimeter. Number 1. Ice must be cleaned using blotting paper. Blotting paper. Insert 1 ice cube at a time. Using meshed stirrer. Ice cube must be below the water level. Below water level. Quickly transfer ice without splashing water out. Without splashing water out. Next one is make sure dew doesn't form. Okay, no? Make sure dew doesn't form. Okay, no? Small ice cubes, add small ice cubes. Right. When stirring the ice and water mixture, ice pieces should not float in water. Yes, very good. What's the reason for this? If ice is floating in water, what will happen? It will start absorbing heat from the environment as convection. Right there. Ice will absorb heat from the surroundings. From the surroundings. Clear? Therefore, we want to make sure what experimental procedure the student should follow when obtaining the final temperature. So, what's the experimental procedure? So, continuously stir just before dew forms. So, insert ice until it is 5 degrees below room temperature. Stop inserting ice. Stop inserting ice and continuously stir. Continuously stir until minimum temperature is reached. Until minimum temperature is reached. Minimum temperature is reached. Okay. Until minimum temperature is reached. So continuously stir until minimum temperature is. So insert ice until it is 5 degrees below room temperature. Stop inserting ice and continuously stir until minimum temperature is reached. And we make sure dew does not form on calorimeter. That's a very important condition. Huh? Dew should never form. Right. A student obtained the following data. Calculate the specific heat of fusion. Heat given by water and calorimeter. Heat absorbed. Heat given by water and calorimeter. Heat absorbed. So heat given 40. Temperature change 35 minus 25. Initial mass 0.1 4000. 35 minus 25. Heat absorbed by ice. Mass of ice melted 0.11 over 1000 0 11. Latent heat of fusion 0.011 plus 4000 multiplied by how much? 25 minus 0. So 11 grams convert to kilograms. 11 grams convert to kilograms. You get your answer. LF equals 3 10 to the power 5 joules per kilogram. Joules per kilogram. Specific latent heat of fusion of ice. Right. Part G. On another day when the room temperature was same, so room temperature same, student repeated the experiment with the same amount of water, but he observed that dew was formed and finished. Dew is forming means what? What do you mean by dew forming? water vapor in the atmosphere is emitting energy and condensing. So now what happens? Why do we say do not form dew? Because water vapor emits energy, that energy is also absorbed by ice. We don't know how much, but it's absorbed by ice. Yeah. So if you take the surface here, water vapor condensers means gas has become liquid by emitting heat. This heat sometimes might be absorbed by the ice. We don't know. That is why we don't want ice, to form. But anyways, the final temperature is 25. The mass of ice melted now is 18 grams. We have melted 7 grams more. Right. Mass of dew formed is 0.86 grams. Assume that the dew point is 25 and the heat released by condensing water vapor is completely absorbed by the calorimeter. Calculate the specific heat of vaporization of water at this temperature. Right? Think carefully and answer. Normally, if there was no dew form, 11 grams was melting. 11 grams. Now we melted 18 grams. 7 grams more. Who helped to melt this additional 7 grams? Condensation or dew formation. So, you can write like this. Heat absorbed to melt additional ice. Melt additional ice is given by condensation of vapor to form dew. Right. So 18 grams, so additional 7 grams. 7 grams of ice convert to kilogram. Latent heat of fusion. Latent heat of fusion. That additional 7 grams, 4000 becomes 25. Condensation of water vapor. Water vapor at room temperature will condense because they are giving dew point at 25. Mass here 0.86 gram. Convert to kilograms. Vaporization at 25 degrees Celsius. Vaporization at 25 degrees Celsius. So here 7, 3 10 to the power 5 plus 7 times 25, 0.86 thousand, latent heat of vaporization 25. Please simplify this. So logic, no? The additional ice melted is because of what? Dew formation, dew emitting heat. This heat only is melting additional ice. From this simplification, what will you get? LV 25, 3.26, 10 to the power 6 joule per kilogram. 3.26, 10 to the power 6 joules per kilogram. Right now. So this is a very good question they have asked. Huh? What will happen when dew forms? Additional ice will be melted. Don't forget. When dew is formed, MCQ also. When dew is formed, additional ice can be melted because some more heat is given by the formation of dew. Okay. Some more heat is given by the formation of dew. Right. Essay question. Essay question. Right. Draw the usual ray diagram. Show that the angular magnification of the compound microscope. Show that the angular magnification of the compound microscope is given by L over F naught, 25 over Fe, when microscope is adjusted to form the final image at infinity. That means alternate adjustment. Here F naught is the focal length of the objective, Fe is the focal length of the eyepiece, and L is the distance between the focal points of the objective and the eyepiece, lying between the two lenses. Here all distances are in centimeter. Right. So here objective has a smaller focal length, So keep a rule and draw this. F naught, F naught. What do? I keep an object slightly beyond the focal length. Slightly beyond the focal length. What happens is light rays which are parallel will go through the focal. Light rays going through the optical center keep on traveling, they meet here. When they meet here, that's where the image is formed. That's where the image is formed. Image from the objective. Image from the objective. Here let's say H, here let's say H dash. Now what happens? Now these two rays, think carefully. Right. Now here what we do is, light rays come here, light rays come here. Final image formed at infinity means focal length of eyepiece should be here. Focal length of eyepiece should be there, right? Focal length of eyepiece should be there. Right. Okay. So what will you get from here? Okay. Right. These rays also enter the eye. This is how you should draw it. Huh? Right. Okay. So here F naught. Right. Now what? Angular magnification. Interesting. Also we keep the object. Also we keep the object. Also we keep the object at the least distance of distinction. At the least distance of distinction. Angle subtended on the eye is alpha. Least distance of distinction 25. At once we'll put 25. At once we'll put 25. 25 cm. Right. Here beta. Here beta. Right. So this is your ray diagram. So you must draw it. Please remember, continue the same ray until it goes to the eye. Very important. Now look at the board. How will I simplify this? I need to simplify this. I need to find that answer. Right. So I'll keep the picture here, I'll go to the board. I'll keep the picture here, go to the board. Right. Tan alpha is equal to h over 25. Tan beta is equal to h1 divided by Fe. H divided by Fe. Alpha beta very small. Alpha beta very small. Tan alpha is approximately alpha. H over 25. Tan beta is approximately beta. H1 over Fe. Angular magnification. Angular magnification is beta divided by alpha. Beta is equal to H1 divided by Fe. Here H over 25. So angular magnification is H dash over H. 25 divided by Fe. 25 divided by Fe. What is h dash over h? Image height over object height. Image height over object height. Right. Now look. What do they want us? L over F naught. L over F naught. What is L? L is the distance between the focal points of the objective and the eyepiece lying between the lenses. Right, let me look at this. Here L. So here F naught, here L. This part is Fe. So looking at this, I can have a clear understanding. Image distance is F naught L. Object distance here is U naught. Object distance is U naught. Right. Okay. So 1 over V minus 1 over U equals 1 over F, objective. Objective lens. U naught minus F naught plus L minus F naught. 1 over F naught plus L, 1 over U naught, 1 over F naught. Simplify this, multiply 1 plus F naught over L, U naught, F naught over L plus F naught. This is your magnification, simple M. F naught plus L over F naught. This belongs here as well as there. F naught plus F naught is 1. L over F naught. 1 1 cancel off. M is equal to L over F naught. M is equal to L over F naught. M is equal to L over F naught. Right. Now I can go back. Just to show it here. Actually, no need, I can show it there itself. So, here the magnification, linear magnification, simple M. Capital M is equal to L over F naught, 25 over Fe. L over F naught, 25 over Fe. There you go. See, that's what they want. L over F naught, 25 Fe. Yes, correct. Correct, huh? Correct relationship. Right. What are they asking? When the microscope is used, care should be taken to eliminate the specimen to achieve better viewing. Now, bio students do this in the lab. Your specimen is eliminated from below, so you can clearly view. Clear. You can clearly see. The following figure shows an arrangement consisting of a lens combination and a lamp used to illuminate the specimen S. The microscope is indicated by X. Right. Microscope is indicated by X. Okay. Right. Each lens has a focal length of 20 millimeter. 20 millimeter. That's the microscope. These are specimens. Filament C has an effective diameter of 2 millimeters. So here object height is given 2 millimeters. Distance A and D are adjacent, so that the image of the filament formed by L1 is positioned on L2 and fills all of L2, right? This image completely fills here. Image of C. Right. Image of C. Okay. What is the, now you can see this clearly. In this situation, what linear magnification does L1 produce? Linear magnification, image distance or object distance. D over A, no? D over A. D over A. So, linear magnification, that is equal to image height over object height. Image height is diameter there 20, object height is 2, magnification is 10. Magnification is 10. Right. What are the values for A and D? Oh. What are the values for A and D? So here 10 is there. So maybe 20 and 2 is also okay. 10, no? 20 and 2 is also okay. So but we don't know this. So we will say D over A is equal to 10. D equals 10 times A. D equals 10 times A. Okay. D equals 10 times A. Now what? You can apply for this focal length. 1 over V minus 1 over U equal 1 over F. U is equal to A. Image distance minus D. Focal length is minus 20. 1 over D plus 1 over A is equal to 1 over 20. D equals 10A. So we can easily say here 1 over 10A plus 1 over A is equal to 1 over 20. 10A, 1 plus 10, 1 over 20. Here 11 over A, 2 here. A is 22 centimeters. Centimeters or millimeters, depending on what's the basic unit. Can't be meters, it may be millimeters. All distances are in centimeters. So we can say centimeter. A 22, D is 220 centimeters. But we have a problem. If these millimeters, then these millimeters. Sorry. So these millimeters. Because this is millimeters. These millimeters. So here millimeter, millimeter. So click quickly, you should click what you are applying. Right. Okay. For better view, the specimen S should be placed at a point where the image of L1 is formed by L2. Image of L1 is formed by L2. What is the value of B? Right. So the specimen should be kept where the image of L1 is formed by L2. What is it? Call it the eye ring. Wherever the object is, the objective lens will act as the object for the second lens, forming the image. So this distance here, D, is important. This will act as your lens, forming the image at the eye ring. Specimen at the eye ring. The small sign, right. This is just like the eye ring. This is just like the eye ring. Eye ring. Wherever the object is kept. Wherever the object is kept. Wherever the object is kept. The image of lens L1, the image of lens L1, sorry, wherever the Object is kept. L1 will act as the object for L2. L1 will act as the object for L2. L1 will act as the object for L2, forming the image at the eye ring. Forming the image at the eye ring. Right. So I think we know the distance D. No? So 1 over V minus 1 over U equals 1 over F. We are applying for L2. Object distance is where L is. So here in this case 220. B we don't know. We don't put the symbol also. Minus 20. 1 over 220 minus 1 over 20. Common denominator 220, 1 minus 11. Minus 10 over 220. Turn upside down. B is equal to minus 22 millimeters. Right? Minus sign means 22 millimeters. Distance B is 22 millimeters. Distance B is 22 millimeters. Right. What is the illuminated area of the specimen? Illuminated area of the specimen. What is the area illuminated by the specimen? Here. Now, light rays coming from here will form the image here. So wherever light rays come, it will form the image here. Right? Form the image where the specimen is. Form the image where the specimen is. Right? Okay. So now what are the distances? 22. 220. 22. Right. Now what will happen? Here 220, here 22, here 22. What are they asking you? They are asking you where the magnification takes place. The diameter of this. There. Diameter of this basic specification. Right. So we know the diameter here. Here 20. Diameter here. 220 millimeter. D is 220. And 22 there. Right. Have a look. So light rays coming from here, has illuminated this. Whatever said and done, illuminated that. Right. Okay. They are asking the area of illumination. Area means first you must find the diameter. No? Yeah. Area means you must first find the diameter. No? Right. So if you work the problem out, basic work, concentrate, tan theta opposite to adjacent, tan theta opposite to adjacent. Right. So if I take this as x and x, Look at the board. Tan x. Opposite is half the radius. 20 millimeter divided by 2 over 20 millimeter over. Now they are saying the diameter. All diameters here. All diameter 20. 20 millimeter here divided by distance 220. Divided by distance 220. Divided by distance 220 equals opposite. New diameter d dash divided by 2. Distance there is 22. Distance there is 22. B distance is 22. Simplify this. 2 cancel off. 20 divided by 220. D dash divided by 22. 22 times 1, 22 times 10. D dash equals 2 millimeters. So area of illumination pi r squared 1 millimeter 10 to the power minus 3 squared. 3.14 10 to the power minus 6 meter squared. 3.14 10 to the power minus 6 meter squared. So I have found the area of illumination, means I have found this diameter. This diameter is found. D dash. Once I know the diameter, I can find the area. There. Once I know the diameter, I can find the area. Okay. Right now. Okay. So that concludes week 6, day 2. So how many MCQs have we completed? We have completed 5 weeks, 340 MCQs. 17 structured essay, 17 essay. That's a huge amount of work with a huge amount of knowledge addition to your knowledge, to your head. So keep working. See you tomorrow at the same time. Week 6, day number 3. Stay home, stay safe, work smart. Good night.